We are in chapter 5 here, and this is the part where it gets very detailed and a little bit boring. So the class kind of starts with the market itself, right? We talk about supply and demand, and then we go behind the demand curve, which is elasticity, and then consumer theory. We're kind of pulling back, and we're going to go behind the supply curve here. Most of us are not suppliers, so this is generally more difficult than consumer theory, and there's also just a lot here. So what I'm doing is I'm breaking this chapter into 2 weeks, so we're going to understand the production side this week and the cost side next week. Once you understand this, everything else is going to make more sense. So after we get past this part, we're going to be able to introduce perfect competition, monopoly, monopolistic competition, etc. We're going to bring back the demand curve. So with that said, there are a few things in your chapter that we are skipping. Number one, isoquants and iso costs. This is similar to indifference curves, and I just don't think that we need to do that. I actually didn't teach it last year again too. I just found it was a sticking point for students and the benefits did not outweigh the costs. We're skipping regressions as usual. I'm going to mention the algebra, but I don't really see the point of covering algebraic functional forms if we're not going to use calculus to get marginal products and stuff. So I'm going to mention it, but we're not going to cover those much, which means everything else is going to be a big focus. So we need to understand all the little pieces of it. Like I said, the costs are going to be next week. We need a firm understanding of production first. Okay, look at all this stuff that I've done. Like I say, we really need to understand every little detail, so I've provided all of these practice things. I've got them all in a folder on Blackboard, so you can click through as we go. You'll probably be pausing these lectures quite a bit, but this is the best way that I've found to teach it, so that's what we're going to do. So the first thing is a production function. So a production function is a mathematical function that defines the maximum amount of output that can be produced with a given set of inputs. So I used to have a professor, maybe I've mentioned this, and he said math is a language. That's all this is here. It's a language. It says the quantity produced is a function of K, which is capital, and L, which is labor. So we're not assuming a functional form here. We're just generally saying, hey, it's a function of these two things. So I've actually pulled up the algebraic functional forms from earlier in the chapter so you can see different types, okay? So we don't know what the functional form is. One type is linear. A linear functional form would be A times K plus B times L. There's this other one called a Leontief. I have not done this since my PhD program. I don't know that this is super helpful, but this would be when inputs are used in fixed proportions, so it's the minimum of these. The best example would be like a shoe for your right foot and a shoe for your left foot. Like you need them together. So the minimum, like if I only have 5 right shoes and 10 left shoes, I really can only have 5 pairs of shoes. Whatever, you don't need to know that. And then the Cobb Douglas one, this is actually really important, especially if you take macro next semester. This is what we assume for aggregate production functions or like an economy-wide production function. It's got all these desirable outcomes. It's super common to see in economics, but we've got Q is equal to K to the alpha times L to the beta. So these are like, again, we don't assume a functional form. This is the generalized form. This is when we start to assume things. Your book actually doesn't talk about this here, but you would actually need not a quadratic, a cubic functional form to get the areas of increasing and diminishing returns. So like, even though we talk about these, they're not the one that's behind the graphs we see. Last little bit about this, we could take a linear production function and let's just say, all right, we have 3 units of capital, 7 units of labor. How much would we produce? 51 units. Okay, so we've got capital, labor, they're somehow related, we get output. All right. Now it's really important to distinguish between the short run and the long run. So in the short run, some factors of production or inputs are fixed. So like usually we would assume capital is fixed. We have some amount of machines, we can vary the labor. We've also got firm entry and exit not being possible. So like if the firm is really profitable, we're not going to see a bunch of new firms open in the short run. This is just a notation thing in your book. When you see a little asterisk here, it's assuming the thing is fixed. So this is a production function. Q is a function of capital and labor. The amount of capital is fixed, so that tells me that is a short run problem. Long run, a period of time which all factors of production, which are inputs, are variable and can be adjusted by a manager. So like this is long enough that the manager can buy a new pizza oven if it's a pizza shop. Machines can change, you can move to a bigger location, everything's variable in the long run. And firm entry and exit is possible. So if the pizza industry is really profitable, in the long run, you're going to see a bunch of pizza stores pop up. All right, so what I'm going to do is I'm going to move over to our first table here. And this is from another textbook that I use, but I really like it. So I've got the units of X, or I'm sorry, the units of Y, 1, 2, 3, 4, 5, 6, that should be a 7, 8, okay? And then units of X, 1, 2, 3, 4, 5, 6, 7, 8. All right. So if I was to say this is a long run issue, the entire table is relevant. So I could increase capital to 4, I could increase labor to 4, and then I've got 60. Okay, let's say double all inputs. So I'm going to increase capital to 8, increase labor to 8, and we see that the production increases. That would be an economies of scale or diseconomies of scale question, which we're going to talk about next week. But if we're concerned with the short run, what we do is we hold something constant, okay? So I'm going to hold the amount of Y constant. The amount of Y is fixed at 2. So then what I can do is I can pull this information about X into its own separate table. And that's really what we're going to start with in chapter 5. So if there's 0x, then we've got 0y. All right. If there's 1x, we've got 7, not y, 7q. 7 is produced. We see that right here. If we increase it to 2, we've got 18. Wow, that's a typo. If we increase it to 3, it's 29, and then it's 40, and then 48. See this? We're constraining y, so this is a short run question. Going back, we've got measures of productivity. So this is the only thing you can do is just go through the formulas. Total product is the maximum level of output that can be produced with a given amount of inputs. Average product is total product divided by the number of inputs. So we've got the average product of labor, which is Q over L. Total product over the amount of workers. Average product of capital, Q over K. And we've got marginal. Marginal is always one more, okay? So the marginal product of labor is the change in total product over the change in workers. Or you could think the increase in total product if I hire one more worker. The increase in total product if I get one more machine. Okay. So these are short run, right? These are short run concepts because we're holding something constant. Average product of labor, we're assuming capital is held constant. So let's actually go back to my table here and let's calculate the marginal product. If you go from 0 to 1 workers, your total product increases by 7. If you go from 1 to 2 workers, total product increases by 18 minus 7, which is 11. Then if you get one more, total product increases by 11 again, and then 11, we've got it oddly consistent here. But then we enter this period where if you go from 4 to 5 workers, it only increases your total product by 8. Then if you go from 5 to 6, it only increases total product by 4, etc. We're going to see that this is diminishing returns. Average product, you just take total product divided by the units of variable input X, which I'm kind of just calling labor here, and it looks like this. Okay. So, consider the following production function where 5 units of labor and 10 units of capital are combined to produce 150. So Q is 150. Calculate the average product of labor. You would take 150 divided by 5. Compute the average product of capital, 150 divided by 10. Okay, and that's what we get. All right, so at this point, what I want you guys to do is go to the first and second video links. The second one is kind of long. I don't know that you have to watch the whole thing. I kind of fast forwarded. The first one, I do want you to watch the whole thing. The second one is like an experiment that you can do in your own classes. So pause that. I'm going to do the same so I remember what it talks about. Okay, so I just watched that again. Usually what I do in class when I'm teaching in person is I make up some sort of game. You can find these all over the teaching blogs or whatever. I'm sure some of you guys have them too. But usually what I do is I have students like create some product, like they have to fold a paper and then put an X on one side and then an O, and I have fixed markers and a fixed desk, and then I keep inviting students up, and then basically the first student is like really productive, the second is very productive because they can specialize, and then we get to the third and it like maybe they're still helpful, and then we get to like the 10th, and the 10th one is just standing there and getting in the way. So you can see diminishing returns through that way. But I like this video, the first one especially, because it's hiring waiters, and I always like to think, you know, the restaurant size is fixed, the waiters are variable, and as you hire them, first you're going to see increases, and then eventually you'll see diminishing returns. So that's a super important concept. So what I'm going to do is I'm going to move to the math. I'm going to move to the table here, and this is table 5.1 in your book. We've got capital being fixed. So a lot of times I'll say, is this a short run or a long run question? This is short run because something is fixed. Variable input is labor. I don't like this column. I don't know why we need a change in labor of 1, but whatever. All right, we can see it, right? Labor increases by 1. Q, total product. It goes up. All right. When we calculate marginal product, it's going from 0 to 1. Total product increases by 76. As we go from 1 to 2, total product increases by 172, etc. You can see average product as well. So we see two really important things here. The first is increasing returns, and this is specifically increasing returns to labor. Adding additional workers is really, really productive. It's even more productive. The second's more productive than the first. So we've got increasing returns all the way up to 5 workers. So that is, I guess, up to 6 workers, depending on how you count that. So basically what happens is there's specialization, right? If they're making pizza, someone can roll out the dough, someone can cut the cheese, someone can put the cheese on it, someone puts it in the oven, someone takes orders, whatever. But then we hit the point of diminishing returns here. So we see it's still beneficial to hire people, right? So it's beneficial to hire them up to the 10th worker, but you never would want to hire that 11th worker because that 11th worker is just getting in the way, and that's negative returns. Okay, increasing returns, diminishing returns. How many workers should they hire? Well, it depends how much the product costs, like how much the revenue the product is bringing in, and it also depends upon the wage. You can also see they calculate average product of labor here. So what I normally do at this point is I hand out a worksheet. I use a lot of in-class worksheets. I highly recommend trying that out. It's going to help you connect some dots before we move on to the graph.